All right, we're looking at 3.5b. All right, so our goal here for 3.5b is to find an inverse function, okay? And just remember, an inverse function, it switches the x and y values. All right, so that is our basic definition that we have for inverse functions. That's really how I want you to think about them. All right, so I'm going to run down the steps of finding these things. So steps to find f inverse of x. All right, remember this is how we say f inverse. So our first step is really simple. All we have to do is a little bit of housekeeping. So step one, replace f of x with y. And that's it. So I'm going to rewrite the function, but instead of f of x, it's going to say y. Don't skip that step. A lot of people try and skip that step, and they really screw this thing up. Step two, switch x and y. Step three, this one's going to be the tough one sometimes, but if you just follow through, it's really not that bad. So solve for y, and finally step four, we're going to replace y with f inverse of x. So really step 1 and 4 are all housekeeping. It's really just how you say what you say. All right, so let's take a look at an example here. The first example we're going to take a look at is f of x equals 3x plus 7. All right, so step 1. All right, real our goal, right? Find the inverse function. So step 1, replace f of x with y. Here's f of x. I'm going to write y. Step 1, check. Step 2, switch my x and my y. Well, here's y, so it becomes x. Here's x, so that becomes y. Step 4, I got to solve for y. So my goal is to get y by itself. And treat x like a number. Treat x like a number, right? But you're not going to add and subtract with it. You can't be like 7 plus x is 11 because I want it to be. No, we just have to. You have to treat it like a number, but we're not actually going to be combining it, so to speak. So here, when I subtract 7 from both sides, I get x minus 7 equals 3y. And then again, getting y by itself, to get rid of that 3, I have to divide by 3. So now, y is all by itself. And on the left side, I get x minus 7 all over 3. Now, for my last, so solve for y all by himself. Now I have to replace the y with f inverse. Well, here's y. I'm going to replace it with f inverse of x. And I get x minus 7 all over 3. All right, well, that's a linear example, right? X is to the first power. Let's try one that's not linear, one that might provide a little bit more challenge to us. Here we go. Let's go with f of x equals the square root of 2x minus 1. Okay, so first step, right? Replace f of x with y. All right, f of x, I got to switch them with y. And I get that. Now we got to switch, right? I'm going to take the y and the x and I'm going to switch them. So instead of y, it's now x, and instead of x, it's now y. And now I got to solve for y. I need to get y by itself. Well, this is where it gets a little tricky. What in the world do I do? How do I get rid of a square root? Well, the only way to get rid of a square root is to square it. So I take the entire side over here and this side over here, and I raise it to the second power. So now on the left side, I get x squared. On the right side, the square root goes away, and I get 2y minus 1. And now I'm just going to continue solving for y. just like we saw in the last problem, this one's not going to be so terribly difficult. And then we divide by 2. All right, and now I get y by itself. And again, the last thing I want to do is replace y with f inverse of x. So x squared plus 1 all over 2. I'm going to do one more here. Okay. Actually, maybe 2 more. What happens if I have f of x equals 1 over x minus 2? All right, again, so I got to replace that with y, so 1 over x minus 2. And now I got to switch my x's and my y's. 1 over y minus 2. All right, now my goal is to get y by itself. Now this looks really difficult because y is in the denominator. But let me show you this trick, this algebra trick that we're about to do. I'm going to add 2 to both sides. So I get x plus 2 equals 1 over y. And now, usually, how do we get rid of the denominator? We multiply it. Well, I'm going to do the same here, but now I'm going to make sure that I keep my left-hand side in parentheses. It's kind of an important thing to make sure that I leave this in parentheses. So when I multiply both sides by y, I now get y times x plus 2 equals 1. As long as I'm leaving that in parentheses, I can now divide by x plus 2. And now y would equal 1 over x plus 2. And now, again, switching this to f inverse of x equals 1 over x plus 2. All right, so what happens whenever I have an x in the denominator, right? Okay, we'll do one more example. And then we'll call it good. All right, last example. What happens if I have a cube? Woo. Okay. Again, first step, replace f of x with y. Switch my x and my y. And now I want to get y by itself. All right, so as we've seen before, I'm going to subtract the 3, divide by 2. So subtract the 3, x minus 3 equals 2y cubed. Divide by 2, so x minus 3 over 2 equals y cubed. Now, what is the opposite of a cube? The opposite of a cube would be a cube root. So now the cube is gone, and I have y on the left side, and now I have the cube root of x minus 3 all over 2. And again, now that y is by itself, I can replace it with f inverse. And I'm done. So it's the idea of undoing. I have to do the opposite to y. I want to get y by itself, and if y has something tricky or different with it, again, once it's by itself, then you do the opposite. The opposite of a cube is a cube root. The opposite of a cube root is a cube. So remember, it's always the opposite, always the opposite.